Hello everyone. Starting from today, we are going to learn some material in chapter 4. First of all, let me talk about derivative of functions, so which written in this form. So WT is UT plus IVT, where U and V are real valued functions. So in this case, we are going to define derivative of function f respect to t. So we define, you can w prime t equals to u prime t plus I of v prime t. So this is easy to get it by definition of derivative. So it's easy to get this one. And we also denote, double prime t equals to dwt dt. So which is used in calculus in college, freshman, you learn in freshman. So this is one of the definition. And then for a function wt equals ut plus I times v of t. So this complex. So in this case, you can consider when t belongs to, let's see, well, can be some region, but let me say R. So let me say t is in R. Then you can consider this complex wt as when t moves. So when t moves, this is wt, and you can consider wt equals ut plus I vt, and then you can identify this point with you can identify this one with ut comma v of t, right? So as a vector, so you can identify like this one, and then you can compute the length distance between 0, 0 and this point. So this is distance, okay? So this distance, the length, so this is the length. In calculus, you learned length is just what? U t squared v t squared, right? So we define, so this is you understand this one, you consider the complex number as a point in plane in R2. So here we define, WT modulus. So now is modulus. This is a modulus is square root. Well, actually, just the modulus is this one, right? So ut squared and v of t. So we don't need to define it because we already defined modulus of complex number before. So we get this one. Okay, this is property. 자, 다시 이야기하면은 여러분들이 이제 이 복수함수가 있습니다. ut 플러스 ivt가 있으면은 이것을 미분한 것을 그냥 u'이라고 쓰고요. 그 다음 dw dt. 그 다음에 이제 의미에 t가 움직이면은 얘네들이 하나의 이제 wt는 곡선 위에 있는 점이 되겠는데 각각의 주어진 t에 대해서 wt의 모듈러스 계산하면은 이게 나온다는 사실을 알 수가 있겠습니다. From here, so you can compute modulus wt squared. That would be ut squared and then vt squared, and then you can differentiate this function respect to t. So we got 2 times ut u prime t plus 2 times v t v prime t. So we end up with getting this one. Okay, this is one of our property. And also, let's compare with the following one. So with the following, we are computing wt squared. So let me compute the wt squared. So wt squared would be is ut plus I times v of t, right? T, and then you expand these out. So let's see, ut squared 2 times I ut v t, and then minus v t squared, right? And you can let me rewrite this one, ut squared minus v of t squared plus 2I ut v of t. Okay, so then you can differentiate this function with respect to t. Wt squared, so this would be 2ut u prime t minus 2 vt v prime t and plus 2I, and then here u prime t v of t plus u t v prime t. So we have this one, right? Okay, well, so you can, and then you can let me check. So then you can simplify this one. So let's see. I can take 2 outside, and then ut. Let's see, ut, and then here I have ut, right? So ut outside. So 2 ut. Let me ut outside. Then u prime t here, and the v prime t. So I have this one, and then so this is gone. So this is gone. And then what do I have? And the v. So I have v. Let me check. Oh, you have v. So 2I. Let's take v of t. So you take v of t outside. So this I have small space here. So let me. So plus 2 v of t I v of t. Let me try to get v of t. So I do have. So here I have u prime t, and here I have minus. So what this one v outside, this minus I v prime t. Is that right? So this minus plus, I have plus t, right? So this is true because minus I here becomes minus 1. So this end up with getting, and now, so this is actually common factor. You can expand factor 2 outside, and then I have u prime t plus I times v prime t, and have u t plus I v of t. So I have this one. So this is just wt, 2 times wt, and then w prime t. Okay, so although this is complex, the complex squared, and you differentiate respect to t, so you got the formula which we obtained in calculus. Okay, so this is very easy. Okay, so now you can differentiate any function which is like this type form. Okay, so let's move on to next one. for this page I don't need to explain in Korean, right? So 여기서 여러분 이제 이제 복소수지만은 복소수를 제곱을 해가지고 그거를 t로 미분을 하면은 그 나오는 공식은 여러분 이제 고등학교 때 배운 두 개 함수의 제곱 미분한 공식이랑 틀리지 않다는 겁니다. Okay, let's move on to do some definite integral case. So now I'm going to define integral. So for Wt equals to ut plus iv of t. So let me define the t is belongs to a and b. So closed interval. And u and v are real valued functions. So where u and v are real valued function. Functions. So in this case, so these are real valued functions. So if u and v are integrable, integrable over closed interval a b, then we define integral. So integral a to b wt dt as u is integrable. You can compute the integral u of t dt, and also I times integral a to b v of t dt. This is very simple definition, right? So this is nothing strange. So this is one of the definition. So we are going to use later on. So once we define this one, and we can move on to next one. So let me give you one example here before we go further. So let's simple example. What would be simple example? By the way, what kind of functions are integrable? Well, integrable function, continuous function, piecewise continuous function, right? So finite, piecewise continuous function means discontinuity, the number of discontinuity are finite. So before give example, so I will give some review from advanced calculus it took in sophomore. So if f is a continuous function on AB, these functions are integrable, and f is let's see, bounded on AB. So let's see, this one, that one, and S is the set, f is x is in AB, such that f is not continuous at x. Okay, this is my set. So this is different function, and then we also assuming that the number of elements in S is finite. Okay, so these two functions are continuous. These are the continuous function. This one is continuous. Second one is bounded function. So bounded function and discontinuity are finite. Okay, so in this case one, case two. Oops. Okay, so these are integral functions. Okay, So then this FR, this F is integrable. 자, 여기에서는 이제 여러분 적분은 WT가 이제 UT 더하기 IVT로 쓰여질 때 U랑 V가 실변수 함수인데 그게 적분이 가능하면은 W에 대한 적분도 이렇게 정의를 한다는 거고요. 그 다음에 이제 여러분 고등비적에서 배운 내용 중에서 F가 연속이거나 그 다음에 F가 바운드이면서 불연속점의 개수가 유한이면은 F가 적분 가능하다라는 걸 우리가 배웠습니다. 이제 그거를 제가 잠시 언급한 거고요. 자, okay. Now let's give one simple example. This part is very easy for you. So let me give one example. So here example. Let's see. 0, 1, 1 plus it squared dt. Well, for this one, okay. So for this one, 0, 1, and then I can expand this out. So this is 1 minus t squared 2it. So let me rewrite I times 2t. Okay, this is real part and this is imaginary part, and I have dt. And then by definition, so this is the same. This by definition, this is 0, 1, 1 minus t squared dt plus I times 0, 1, 2t dt, right? Okay, so this is easy for you. So t minus 1/3 t cubed 1, 0, and then I have t squared 0, 1. So that would be 2/3 plus 1i. So here's the answer. So this is easy, right? Okay. And then you can, this is example 1. Another example, so another example is the following. So I'm not going to do this one. So this is homework. So this is your homework. So integral 0 to 2 pi e to the I m theta e to the minus I n theta d theta. You compute this one. This is exactly if these integers are different. So this 0. If n equals m, what would be? This is easy, 2 pi, right? So where m and m are integer z, okay? I want you to do this one as homework. So this one you can, well, you just expand it out, okay? So this is a very simple but very important property. Okay, this is homework. So 이거는 여러분 집에서 꼭 해보세요. 네. 자, okay. Now next topic is contour. So next topic we're going to discuss about contour. What is contour? Contour is just the path in plane, okay, in complex plane. So I have a complex plane. So here I have a complex plane. So you have a curve here. So start from here. So this is called a contour, okay, or arc, okay, contour or arc. So here, so in our textbook, so a C is a arc. Okay, is an arc if C is written as UT plus VT, so if C is written as C equals UT, comma VT, or T between A and B. So where UT, U and V are continuous function. Okay, U and V are continuous. These are continuous function. Okay, so arc, we have arc, so we are assuming continuous. Okay. So this would be arc, right? This is arc. Okay, now what is a simple arc? So what is a simple arc? Simple arc. This is one arc. Also, you have this one. This is one of a curve in arc, right? So this is closed curve, still arc. So this is arc. Simple arc. Okay, well, this is also arc, right? How about this one? This is not simple arc, not simple. Okay, so simple arc, it means the arc does not cross each other. Okay, here's the definition. So a curve C in complex plane is a simple arc. So let me remove this. This is an arc C. This is C. A curve C is a simple arc if it does not cross each other. Does not cross itself. 자, 다시 이야기하면은 이제 이 arc라는 것은 여러분 이제 C가 arc라는 거는 C가 이제 U, UT, VT 이 좌표 형태로 쓰지면 이렇게 쓰지면서 U가 B가 이제 연속함수다. U가 B라 연속함수일 때 이제 arc라고 부르고요. 그 다음에 이제 simple arc라는 것은 이제 이 첫 번째 이 예제에서는 어떻게 돼요? 이 커브가 이렇게 이제 붙어 있지만 서로 이렇게 가로지르지 않는다는 겁니다. 얘는 가로지르다. 크로스라는 얘는 가로지르다. 그러니까 이렇게 가는 게 얘가 크로스 한다는 이야기거든요. 가로지르다. 이런 경우는 어떻게 됩니까? 이렇게 한번 여기도 여기 많이 가로지르죠. 이런 경우는 not simple입니다. 자, 이런 거는 심플이 되고요. 그 다음에 이제 뭐 이렇게 꼭 이제 이런 것도 됩니다. 각도가 지워지더라도 연속적으로 된 거니까 다 arc가 되는 거예요. 자, 그 다음 이제 so next definition, simple closed contour, simple closed arc, okay, simple closed curve. So here definition. So a curve C. So let's see. C is Here I denote in this way, but you can also denote this one by ut plus I vt. So these are the same expression. So you can identify complex as in identify with the R2. So here let me write down z of t instead of ut. So I have ut plus I vt. So here t is between a and b. So a contour, a curve C is a simple closed curve. So let me, this is a simple closed curve. So then if closed curve means the value and starting point, end point are the same. So these are, okay, then simple closed curve. And C does not cross itself. Okay, C does not cross itself. Okay, so that would be simple closed curve. So what are the examples? So here I have this curve, simple closed curve. How about this one? Okay, this is still simple closed curve. How about this one? This one? Well, you start from here, right? I start from here. I go this way. What did I do? Start from here. I go this way, and then that way, and then go this. Follow this way. Let me use different colors. So follow this way, and then that way, and then end up with here. So this is still close the curve. So this one is close the curve, but not simple. Okay, not simple because they cross how many times? 1, 2, 3, 4, 5. 5 times cross. So this is not simple. Okay, these are very basic stuff. So there's nothing different, no, difficult material here. So we just studying curve. Okay, now from here, what you need to know is when you see a curve, you need to parameterize the curve. So you need to find the ut plus it once curve are given. Okay, so now let me next definition. So we're trying to find the arc length of curve. So here let C be given like this one. So z of t is ut plus I times vt, and t is between a and b, and assuming u and v are differentiable. So u and v are differentiable or piecewise differentiable. So piecewise or differentiable, because these are real valued function, you can talk about if differentiable. And once we have this one, so you can identify this curve in R2 in the complex plane is the same in R2. And here, this is my curve C. So here, my interval. So my interval domain. Oops, let me draw a line here. Okay. something's wrong here. They cannot. Anyway, let me use different color here. So, okay, here's a line. So I have AB. So when t is here, so this is the value UZT. Okay. When t equal A, this is ZA. B, this is ZB, right? And when t moves from A to B, that's the way the curve moves from this one. Okay. And you can compute the length of, this is my curve C. So this is my curve C, and then we can compute the length of T. Okay, the length of C, curve C. The curve C, you can, this is just what? Did you take, when you take a calculus, so you can identify this one as UT, comma VT, right? UT, comma VT, and this is exactly A to B root U prime T squared V prime T squared dt. This is what we learn in calculus. So you just use that. So then you you got A to B, and then my g of t equals ut plus I vt, and this is exactly z prime t. So this is just the z prime t modulus. Okay, complex modulus. This is the arc length. This is the length of a curve C. Okay. And also here, one of when t is here, so this is here. So when t moves from this way, and then the curves move this way, and you can also consider derivative. You can also the tangent vector. You have tangent vector. So you have a tangent vector. You can also consider tangent vector. Tangent vector is just the what? Z prime t, right? This is your tangent vector prime t, and this is the just the what? Just the modulus of tangent vector to the curve. So this is tangent vector to the curve to C, tangent to C. 자, 여기서는 이제 여러분 미적분에서 이제 어떤 곡선이 이제 평면 위를 움직일 때 이제 이 곡선의 길이 구하는 것을 배웠거든요. 그 복소수에서 u 더하기 iv가 나오면 평면상의 점으로 ut, vt로 대형시킬 수가 있는데, 그 공식을 이용을 하면은 C의 곡선의 길이라는 것은 이제 이런 식으로 표현이 되고요. 이걸 다시 원래의 복소수로 생각을 하면은 복소수 z''의 모듈러스가 되는 거죠. 얘는 절대치가 아니라 모듈러스가 되는 겁니다. 그러고 여러분 알겠지만은 이 곡선이 이제 평면에서 곡선이면은 한 점에서 이 점에서의 접선의 방향을 구할 수가 있겠죠. 접선의 방향은 이제 다시 이야기하면 z''이 바로 접선이 되는 거죠. Okay, so today, 자, 그래서 오늘은 여기까지 합시다. 자, 오늘부터 제가 다시 챕터 4는 이제 원래 우리 이 복수 해석하기 영어 강의거든요. 그래서 이제 다시 이제 처음에는 제가 영어로 하다가 이제 여러분들이 이제 공부하는데 도움이 되라고 제가 한국말로 하다가 이제 마지막 챕터 4에서는 실제적으로 제가 이제 판서를 해가면서 이제 영어로 이제 이렇게 수업을 해도 이제 여러분 학습을 이해하는데 아무 어려움이 없을 거라고 생각해서 지금부터는 계속 이제 이 영어로 마지막 챕터 4를 하면서 이제 우리 유동의 미를 잘 거두겠습니다. 자, 지금부터는 이제 제가 판서를 예전에는 강의 노트를 만들어 와서 했는데 챕터 4만 이제 실제적으로 제가 강의를 해가면서 이제 판서를 해가면서 수업을 할 거니까 오히려 여러분 공부하는 데는 사실은 강의 노트를 가지고 설명하는 것보다 직접 이렇게 써가면서 하는 게 이제 아마 이해가 빠를 거라 생각을 합니다. 그런데 진도가 늦을 때는 이제 제가 강의 노트를 만들어서 또 읽을 수도 있어요. 그래서 이게 주로 진도를 빨리 나가려면은 노트를 만들어야 되고, 진도를 천천히 나가려면은 이제 이렇게 강의 노트를 실제적으로 하면 여러분 더 쏙쏙쏙 또 이해가 나올 거라 생각합니다. 중간에 가다가 혹시라도 또 진도가 늦다 싶으면 제가 노트를 만들어서 또 진도를 빨리 나갈 수가 있어요. 하여튼 수고하셨습니다.